So Leetcode problem of the day, and here's the runtime error brings a solution for you. Just in case if you're new to our channel, I highly recommend you to subscribe the channel to get the daily updates on Leetcode solutions. So let's start with today's question, that is minimum cost climbing stairs. I'm going to solve this question in 3 different steps, so I highly recommend you to watch the video till end so that you can come across a detailed solution for today's problem. So what does the question says that we have given an integer array cost where cost of I is the cost of ith step on the stair. One of the most important point to notice here that once we pay the cost, we have the two options. That is, either we can climb one step or we can climb the two steps. Right? For every step, say for example, I'm standing over here. I have the two options. Either I can jump at one position or I can jump at two position. And second important point, that is I can start at index 0 or I can start at index 1. There is no any bound that we have to start from the first index of my array itself. No, I can start either from 0 or I can start either from first index. And at that, what we need to return is we need to return the minimum cost to reach at the top floor. So we need to return the minimum cost to reach at the top floor. So what does this top floor, how to calculate the minimum cost, let's check in detail. Now say for example, this is my array and TF simply means a top floor. So this is my top floor which is present after the end of my array, right? So this is not our top floor. The top floor is present after the end of my array. So what I will do is, in the first scenario, I will be starting from index 0, right? Now since I'm starting from index 0, I have to pay that much amount of cost in order to jump. So first of all, I will pay the 10 rupees to jump. Now I have two options, that either I can jump at one position or I can jump at two position. So what I will do is, if I jump at one position, again I need to pay 15 rupees. So rather than jumping at one step, I will try to jump at the two steps, because at the end what we need to return is we need to return the minimum cost. So what I will do is I will jump at the two steps over here. So right now, right from this position, I came at this position. So this we took a 2 jump, right? Now still I'm not present in my top floor. Still I need one more jump. So what I need to do is, in order to jump 1 or 2 steps, I have to pay this much amount of cost. So again I'm going to pay 20 rupees and then I will jump one step, because I will reach on the top floor in just one step. I don't need to jump 2 steps. So what is the total cost required to reach at the top floor? That is, I need 30 rupees, right? So what I did is I took the start from this position, right? I started from index 0. Now let me start from index 1. So we will check what will be the total cost to reach at the top floor if we start from index 1. So since I'm present at index 1, I need to pay 15 rupees in order to jump. So I will pay 15 rupees. Now again I have two options, either I can jump one step or I can jump two steps. But here we can say that if I'm jumping one step, again I need to pay 20 rupees in order to go at top floor. So I will not choose to jump one step because I need a minimum payment. So what I will do is, rather than jumping one step, I can directly jump at two steps and reach at the top floor. So I will directly go over at this position. So what is the total cost required to reach at the top floor? 15. So here I took 30 rupees and here I took 15 rupees. So what is the minimum of 15 and 30? Of course it will be 15. So can I say that I need to start from index 1 in order to reach at the top floor in the minimum cost, that is 15 rupees. So I hope so you understood the meaning of the question. Now let's try to analyze how we can derive or draft a solution for this problem. Now let's start with our analysis 1. So what does the question says that in our question we got two options, that is either I can have jump 1 or I can have jump 2. Say for example, if I'm standing at this index, I have the option either I can jump from this position to this position or I can jump from this to this position. So I have the options, or can I say I have the choices to jump. And always remember that whenever we have the choices, what comes in our brain? For sure, the one thing that comes on our brain, that is recursion. Because what we need to do is we need to carry out both the choices in every single index. From this position jump 1 and 2, from this position jump 1 and 2, from this position jump 1 and 2. So we will carry out all possible choices on every single possible index, so that at the end we can get the minimum answer, right? Because we don't know from which position what jump I should take so that I can get the minimum answer. So rather than searching for it, what I will do is I will carry out all possible choices, and I have two choices, that is jump 1 and jump 2. So from this position I will jump 1 and jump 2. Again from this position I will jump 1 and jump 2. Again at this position I can jump 1 and jump 2. So all the possible choices, whatever the minimum answer I get, I will simply return that minimum answer. So whenever we are dealing with the recursion, always remember the three important steps. So number first steps is express in terms of index. And the second important thing is carry out all possible stuff. Carry out all possible stuff. And at the end what we need to return is we need to return the minimum answer, right? So these are the three important steps that we need to follow in order to carry out the solution of this problem. So let's try to check how we can derive the solution for this problem. Now as I told you that whenever we have the choices, what comes in our brain, for sure the one thing that comes on our brain, that is recursion. Because what we need to do is we need to carry out all possible choices at every single index, that is index this and this. Means at every index I'm trying to carry out all possible choices. So one thing that came to know that I need a recursion to solve this question. So how can I use recursion to solve this question? The number one step is I need to express in terms of index. What does it mean yet? At every single index I will carry out all possible choices, right? So I need to make use of indexes. So here I need index. Second important thing is carry out all possible steps. So we have two options, that either I can jump one step or I can jump two step. So what I will do is at every index I will jump one step, I will jump two step. Again at this index I will jump one step, I will jump two steps. Again at this index I will jump one step and I will jump two steps. So at every single index I will carry out all possible choices. And at the end, whatever the answer I get from all possible choices, I will simply return which is the minimum answer of it. Because in question they have asked the minimum cost to reach at the top floor of my array. So I hope so you understood this. Now again we got the two options to start my questions with, because what they have told us, we can start either from my 0th index or I can start from my first index, right? So what we will do is we will get to two functions. So function first, this will contain my size of my array and this will be my index. And this is my function, again this will be my size of my array and this is my index 1. So what we are doing here is we are starting from index 0 and here we are starting from index 1. And then what we will return is, but then if you're calling these two functions, simply what I will do is I will simply return the minimum of these two, right? Minimum of these two. So I will call the two function, one is from index 0, that is index 0, and one is from index 1. So out of these two function, whatever the answer I get from both the function, I will simply return the minimum of it. So I hope so you understood the little bit intuition of this question, how we can solve this question. Now let's try to define the solution for this problem. Okay, now let's try to define the solution. So first of all, we will be discussing of index 0, because as it is mentioned in the question, we have option that either I can start from index 0 or I can start from index 1. So for the first point, we are discussing for index 0. So what I will do is I will simply define a function called as f. This is my array, this is my size of an array, and this is my index, right? And I'm starting from index 0. So what I have two options, right? Either I can jump one step or I can jump two steps, which means I have the two choices. So what we have decided is, as it is mentioned over here, at every single index we will carry out all possible choices. So what we will do is, since I'm standing at here, I will carry out all possible choices, that is jump 1 and jump 2. Again if I come over here, I will have two choices, jump 1 and jump 2. So at every possible index we will try to carry out all possible choices. So simply what I will do is, first of all I will declare a variable called as 1, where we will be taking one step. And how much cost do we need to pay? Since we are starting at this index, we know that in order to jump I need to pay this much amount of cost. So simply what I will do is, first of all I will pay the cost present at particular index, and again I will be calling the function. And how many jump I need taking first? I'm taking first one jump, right? I'm moving from this to this, which means I'm taking jump 1. So simply I will increase the index value by 1. Again one more choices I have, that is since I'm standing here, I can take one jump or I can take second jump. And since we take the first jump, now I have the option to take the second jump as well. So I will declare the variable called as 2, right? What does it 2 means? This is 2 jump. But the point is, can we take this 2 directly? Say for example, I'm standing at this position. Can I take the 2 index, 2 jumps? No, because anyhow my top floor is present at this point. Let me show you. As I told you that my top floor present at this position. And say for example, I'm standing at last index, I'm trying to take 2 jumps. Is it possible? No, because I'm trying to get beyond my top floor. What does the question say? That I need to reach at the top floor. But from this position, if I try to jump 2 steps, I'm going beyond my top floor. So I cannot jump 2 steps if I'm standing at the last position. So can I say, if I'm standing at the second last position, I can take directly second jump, right? So that's the reason why I need to mention a condition that if my index is less than n minus 1. So what does it mean is, I'm standing at this position, because from this position I can directly go to the top floor, right? But from this position I'm trying to go beyond my top floor. So then and then only I can take a second step. And how many amount I need to pay? Index on which I'm standing. So simply what I will do is I'll simply carry out ARI. Again, this is my size of array, and now I'm taking the 2 steps. So I'll simply increase the value by 2, because here we're taking the 2 steps and here we're taking the 1 steps. And at the end, what they've asked, we need a minimum value. So simply what we will return is, we will return the minimum value, right? Minimum of 1 and 2. Minimum of 1 and 2. Now we will think about the base condition. Now say for example, we are going beyond this array, right? I'm standing at this. Do I need to calculate anything? No, because I'm already standing at the top floor of my array. Therefore, can I say if my index is greater than or equal to n, I need to return 0, because I don't need to pay any cost because I'm already standing at my top floor. So this is the function that we calculated to carry out the answer from index 0. Can I say that for index 1, I need the same one? Just in place of 0, I'm going to start from index 1. So this is the same function we will use to carry out from index 1, right? Simply in place of 0, I will pass the index as 1 and I will carry out all the tasks, because I am starting from this position, jump 1 and jump 2. Similarly, rather than starting from index 0, I will start from index 1. So I have the option jump 1 and jump 2. And at the both the function, when I get the both the function for index 0 and index 1, I will return the minimum of it. So I hope so you understood the basic solution of this question, that is using the recursion. Now the problem is, since I'm using the recursion, there might be a possibilities of overlapping subproblems, because what we are doing, we are carrying out all possible choices and we are having more than one function call in a same function. Therefore, there is a high probability of getting the overlapping subproblem. So once we are having the overlapping subproblems, what comes in our brain? The one thing that comes in our brain is for sure, that is dynamic programming. Now let's try to implement this question using dynamic programming. Now this is the solution we discussed previously, that is we will be having a same function but we will be calling it 2 times. So first function is called for index 0 and again I call the same function for index 1, and at the end what we'll do is I will return the minimum of both the index. So simply I will get the minimum of function, that is ARI n and 0, because this is starting from index 0, and again I will be calling the same function, but only a thing is I will be passing index as 1. So here I have passed the index 1 and here I have passed the index 0, because in the question it is mentioned that either we can start from index 0 or we can start from index 1. So at the end, whatever the answer we get from the both the function, we will try to get return minimum answer of it. So I hope so you understood the recursive solution for this problem. But as I told you that it contains more than one function call, therefore there is a high probability of getting the overlapping subproblems, right? And there is only one solution is present to get rid of overlapping subproblems, that is dynamic programming. So we will analyze how we can make use of dynamic programming over here. From this function, we can come to know that there are the 3 parameters I am passing to the function. Which are those 3 parameters? I am passing ARI, which is my array. This is my size of an array. I am passing the index. And throughout these 3 parameters, which is the parameter which is changing? Is my array changing? No. Is my size of my array changing? No. But the point is my index is changing. My index is increasing either by 1 or my index is increasing either by 2. Which means, can I say that my index is only a parameter which is changing, which are those out of all 3 parameters? Because my array is not changing, my size of my array is not changing, only my index is changing, right? Therefore, how much dp we require? 1 dp, 2 dp or 3 dp? How we will analyze? This will analyze on the basis of number of parameters changing in my function. So there is only one function parameter which is changing, that is index. Therefore, we will be having 1 dp, right? We will be having 1 dp. Now, what is the maximum value my index can have? Since my index is starting minimum value from 0 and it is getting to end at n-1. Therefore, can I say that simply I need vector or dp of size n, right? I need size n. Or in Java, you can simply declare this array of dp of size n, right? Of size n. And what we will do is we will initialize all it by -1. So initialize all the value by -1. And simply we need to add 2 sentences in our solution, right? So what I will do is I will copy out this same solution and I will add 2 new sentences just to convert it into dp. So let's check a dp solution for this problem. So this is the dp solution. So what I did is I added one sentence: if dp of n is not equal to -1. What does it mean is, say for example, I am calling the function for index 3 and the value for this index 3 is already calculated and I have stored in my dp. So why should I call the function once again and calculate the value for index 3? No, because I have already calculated value. So simply return that value. I don't need to calculate it once again. So I use this sentence. And finally, whatever the values I'm calculating, I'm storing in the DP so that I don't need to get an extra function call and again calling the function for the value which is already been calculated. So that's the reason why for every single calculated value, I'm storing in a DP so that if in case we are getting the extra function call, rather than calling it that function, simply return the value for it. So I hope so you understood that solution for these problems clearly. I tried my very well to explain you this today's Leetcode portion of the day. Now let's move on to the solution for this problem. So this is the C++ and this is a Java code. You can check according to your own convenience. So what I did is, first of all, I calculated the size of my array, right? The same thing I did over here. Now what I did is, as I told you that we need a DP that of size n, and I have initialized to -1. The same thing I did in Java, that I declared an array called as DP and I have all initialized to -1. Then see, I have called this function two times. One is for index 0 and one is for index 1. And what I did is I simply return the minimum of it. Because what they told, we have two options. Either we can start from index 0 or either we can start from index 1. And at the end, we need the minimum cost. What I need is minimum cost. So simply what I did, I called the function for index 0. Again, I called the function for index 1. And I checked which one gives me the minimum answer. And I finally returned the minimum of it. So this is my base case. As I told you that once we reach beyond my array, we have reached the top floor. So I need to return 0 because I don't need to return or pay any cost since I already reached to the top floor. And again, I checked, is there any function whose value is already calculated and stored in my DP? If it is, I don't need to get a function call and again call or calculate the value for that function. So I simply return the value which is present inside my DP. Then I took the first step. And before taking the first step, I paid the cost and I took the first step. So since I'm taking jump 1, I have incremented my index 1. The same thing done over here. Similarly, before taking the second jump, I checked, is it my index less than -1? Because what I told you, say for example, this is my array and I'm standing at index last. And if I take the two steps, I'm going beyond my top floor. That's the reason why I need to make sure I'm present at second last index. The same condition I checked over here. And then I took the two steps ahead. And then what I did is I simply returned the minimum of step 1 and minimum of steps 2. And before returning it, I stored in my DP so that in future, if in case I require that value once again, rather than calling the function again and calculating its value, we will simply return directly from the DP since it saves our function calls. So this is the most easiest problem today we had in the Leetcode problem of the day. And I hope so you understood this question really well. Just in case if you are new to our channel or you are liking the way I'm teaching you, do hit the subscribe button so that I can get motivated and give a much more better solution for you. Till then, I'm signing off.